Okay, so you were asked to find the some vector perpendicular to the vector 3i plus 4j minus 5k. Well, we can do that. Let's just let alpha I plus beta j plus gamma k be some vector with unspecified alpha, beta, and gamma, and let's see what it means for this vector to be perpendicular to this vector. Once we see what it means, we can probably, if possible, of course, choose values of alpha, beta, and gamma that make it so. Well, if the two are perpendicular, their dot product is 0. The dot product of this vector and this vector, as you should know just very automatically at this point, is 3 alpha plus 4 beta plus minus 5 gamma. Product of the I components times the product of the j components times the product of the k components. If these are perpendicular, well, then the dot product has to be 0, so 3 alpha plus 4 beta minus 5 gamma has to equal 0. Now, how many solutions are there to this equation? A solution consists of value alpha, beta, and gamma, values of alpha, beta, and gamma that make this equation true. Now, certainly it's true if alpha, beta, and gamma are all equal to 0, but that isn't helpful because that just gives you the 0 vector. We need a non-zero vector that's perpendicular to this vector. Well, there's still many solutions. There are infinitely many solutions. Somebody in the class came up with this one. Alpha is 2, beta is 1, gamma is 2. So if we put in 2 for alpha, we get 6. 1 for beta, we get 4. 6 and 4 is 10. Then if we have 2 for gamma, we get negative 10. Well, that gives us 0. So right there is a vector, is an alpha, beta, and gamma that makes this vector perpendicular to this vector. Okay, well, that's a solution. Okay, so that then the vector 2i plus j plus 2k that we get from these values of alpha, beta, and gamma is perpendicular to this vector. And we can verify that by calculating the dot product. If we've done everything correctly, that's going to be 0, showing that the vectors are perpendicular. Alternatively, we could let one of these quantities be 0 to simplify the process of finding the other two quantities. So if gamma is 0, for example, then the equation becomes 3 alpha plus 4 beta equals 0. And a solution to that's very easy to find. Let alpha equal negative 4 and beta equals 3. Think about why I chose that. Think about how that's obviously going to give us 0 here if gamma is 0. And that, of course, gives us the vector. What? Alpha is negative 4, so it's negative 4i. Beta is 3, so it's 3j. So, and gamma is 0, so we don't have the k, so that 4i plus 3j should be perpendicular to 3i plus 4j minus 5k. If you do the dot product, you'll see that it's so. Okay? Now, there are infinitely many solutions. We could let any one of these be 0, and we have infinitely many solutions for the other two. So there are lots and lots of solutions to this equation. In fact, the set of vectors that are perpendicular to this one well, I was going to say they form a plane. They could form a plane through the origin. Okay, we'll get to a case where you have a plane. But the vectors that are perpendicular to this one are spread over a plane that's perpendicular, and the plane is perpendicular to this vector in the sense that every vector in the plane is perpendicular to this vector. Okay, an alternative way to find a vector that's perpendicular to this one, it anticipates what we're doing in the next section, which is section 2.4, is to pick any vector that's not parallel to the given vector. The given vector was 3i plus 4j minus 5k. Pick any vector that's not parallel to that and find the cross product. Well, the vector 2i is not parallel to this vector, and that's very easy to see. It could be verified. But really what happens if you happen to pick a vector that is parallel to this is you're going to do your cross product and you're going to get 0. because the cross product, well, the cross product is 0 if the two vectors are parallel, just like the dot product is 0 if the two vectors are perpendicular. Okay, so let's let 2i be the vector. Cross that with 3i plus 4j minus 5k. We're going to expand this by the distributive law. So I have 2i cross 3i, and 2i cross 4j, and 2i cross negative 5k. Well, I cross I is 0. Okay, two vectors that are parallel have a cross product that's 0, and I, of course, give you parallel vectors. Now, I cross j, of course we have 2i cross 4j, which gives us 8i cross j. Well, I cross j by the right-hand rule, if the x direction is this way, the y direction this way, the z direction this way, I cross j would, get my hand here so you can see it, okay, fingers along I, turn in the direction of j, cross product is in the direction of positive k. So 2i cross 4j is 8 times I cross j, which is 8 times just k. Similarly, the I cross k vector is what? And I just saw an equal sign here that doesn't belong here. That should be plus. Correct that before I go on. Okay. Well, we have negative 10 times I cross k. What's I cross k? Well, I is in this direction, k is in this direction. My thumb is pointing here in the direction of negative j. So that I cross k is negative j, and I'm not even sure what that 8k is doing there. Refugee from somewhere had it equals 8k, but that's not quite right. Okay, not sure what I did, but this is what never mind. Okay. I hate to take up time to correct this, but should have been an equal sign here. Okay, simplifying what we got here. Okay, so again, the negative 10 I cross k, for the reasons I just pointed out, I cross k being negative j, is going to be positive 10 times j. And then I rewrote that. I didn't have the 0 here, didn't need that. It's just 10j plus 8k. We usually want to write the vector in final form in the order of the I, the j, and the k components, which is why I rearrange it here. So I'm not sure what I had wrong there. I think I had the equal here when it should have been here. So that might have been a little confusing. Anyhow, we can check this. Is this vector perpendicular to this vector? Well, just write it out. Take this vector and dot it with this vector. We should get 0. 10 times, okay. We got j here and j here. 10 times 4 is 40. The k's give us 8 times negative 5, which is negative 40. That equals 0. And we confirm that the dot product is 0, so that using the cross product, we also found a vector perpendicular to the original vector.